Hi all, welcome back to my channel Haron HubSpot. Today I came with a very important concept, how to integrate trigonometric function by using the method of substitution, or how this substitution method is, what is the advantage of substitution method when we compare with the division rule or product rule. Okay, otherwise how we can use this substitution method effectively in solving problems under integral. So I choose the two questions, and by discussing these two questions you will get understood what is the importance of substitution method or how substitution method can be applied. So your first question is, this is your first question, integral 2x sine of x square plus 1 dx, integral 2x into sine x square plus 1 dx. So we can use substitution method obviously here, but is there any other method, other rule? Yes, you can use product rule also. You can consider this as first function, you can consider this as second function, and you can use that product rule, product of integral of first function into second function into dx. That rule can be applied. What was that rule? What is the product rule of integration? First function into integral of second function minus integral of differentiation of first function into integral of second function. No, that was the rule. So as I said, we are not going to use product rule here. The reason is that when I use product rule, I can use product rule easily, but the problem is if we are going to use product rule, the question becomes complex. But when we use substitution method here, this integration is going to be a very easy task for you. You just see. I'm going to replace this x square plus 1 as u. Otherwise, I'm going to substitute this x square plus 1 as u. What will happen? If you substitute x square plus 1 as u, if let u is equal to x square plus 1, then you just take the differentiation of u with respect to x. What will happen? Du by dx. Can you calculate what is du by dx? It's very simple task for you. Du by dx will be what? 2x. This is a constant. X square differentiation is 2x. This is a constant, so its differentiation is 0. So du by dx will be what? 2x. Okay, then what will be du? Take this dx to right side, it becomes 2x dx. Then what will happen? See the magic. Now, the question was integral 2x sine of x square plus 1 dx. So after the substitution, you just see this is 2x dx, no? You can read it as 2x dx. What is 2x dx? That is du. So instead of 2x dx, you can write du, because we calculated that du is nothing but 2x dx. So you can replace 2x dx as du. Then sine x square plus 1. So after the integral sign, we replaced 2x dx as du. Then what is remaining? Sine x square plus 1. So sine, what is x square plus 1? We replaced x square plus 1 as u. So after the substitution, the lengthy problem reduced into a very short problem. So what is integral of sine u du? We know that integration of sine x is minus cos x. So integral of sine u du is minus cos u plus c. The problem changed in terms of u. That is only one difference. And this difference will not create any problem. So it becomes, now it's a time for resubstitution. Minus cos, what is u? What was u? U was x square plus 1. So it becomes minus cos x square plus 1 plus z. So this is the integral of this function. Answer is minus cos x square plus 1 plus z. And we are going to solve one more question, and you may understood that this substitution method is much simpler than product rule. So we are going to discuss one more question. So as the second question, let us choose a little bit standard question, and your question is integral tan raised to 4 root x sec square root x by root x dx. This is the question which we are going to solve now. Okay, integral tan raised to 4 root x sec square root x divided by root x dx. Okay, so my question is, which term I can substitute or which term I can replace? I'm going to substitute this tan root x as u. This is actually tan raised to 4 root x. Suppose if you are going to apply that quotient rule, you may understood that if you are going to use the integral of division, that division rule, it will be in a very complex form if you are going to apply that. But we are not going to apply that. We are going for a substitution method. So which term I can substitute? Many methods are there, and this is one of the method. I'm going to substitute tan root x as u. So let u is equal to tan root x. Let u is equal to tan root x. if you substitute u as tan root x, now it's the time to take du by dx, differentiate both sides with respect to x, du by dx. So what is the differentiation of tan x? Tan x is, tell me, tan x is sec square x. Tan x differentiation is to sec square x. So obviously tan root x differentiation is sec square root x. Then chain rule. So we took the differentiation of tan root x. It is found to be sec square root x. Then it is a time to take the differentiation of root x. Chain rule, no? So what is the differentiation of root x? 1 by 2 root x. So differentiation is over. Now we just see what is du. Du becomes sec square root x. Then 1 by 2 root x dx. I kept du in the left side and I took this dx to the right side. So du by dx was sec square root x into 1 by 2 root x, and I kept du in the left side and I took this dx to right side. So it became sec square root x into 1 by 2 root x into dx. You may understood, no? Now we just see, you can take this to the left side. It becomes 2 du is equal to what? Sec square root x dx. Let it be your some first equation, and let me come to the question. So your question was like this: tan raised to 4 root x sec square root x by root x dx. Now just see integral tan raised to 4 root x. Actually tan root x we replaced as u. So tan raised to 4 root x becomes u raised to 4. Is it clear for you? Then now we just see. Oh, sorry. Here I took 2 to left side, so here I forgot to write that sec square root x, then 1 by root x will remain. So that means sec square root x by root x will remain. Sorry for that mistake. And now just see, it becomes u raised to 4. Now and see, can you replace this sec square root x by root x as 2 du? Because we got that, we understood that sec square root x by root x is nothing but 2 du. So you can replace this sec square root x by root x as what? 2 du. So substitute that, and now it's the time to take this 2 outside. So it becomes u raised to 4 du, and it's very simple. Now very simple. What is it? 2 into integral of u raised to 4 du? It becomes 2 into u raised to 5 divided by 5 plus c. And when you replace u, or when you resubstitute u, the answer become 2 into what was u? Yeah, u was tan root x. So it becomes tan raised to 5 root x. Sorry. It becomes 2 into tan raised to 5 root x divided by 5 plus c, and this is answer for this question. This is answer for the question, and this is a method which we can use substitution in this kind of standard problems. So I think this video was useful to you. If you felt this video was useful, please share with your friends and wait for the next video. Thank you.